Right, now let us take a few examples. Okay, let's say we will take the very first example what we have seen. Okay, so let us try to find the Fourier transform of following signals. Okay, find Fourier transform of. So first signal, we take our staircase signal which we have seen before. So to solve that problem, this problem, right? So we took which property? Linearity property, but we can take the help of time shifting also. Okay, we can take the help of time shifting property. So let me explain that. So we want Fourier transform of this signal. Okay, so this signal can be written as, so before we go into that, let us consider our new signal like this. Okay, let us take a rectangle signal from -3/2 to +3/2 with amplitude 1. Okay, so let us call this fellow to be x1 of t. So now if you look at this signal x1 of t, and yeah, we already know this fellow's Fourier transform, which is x1 of j omega, which is equal to how much here? 2 sine omega t. T is how much? 3/2. So you'll get 2 sine 3 omega by 2 divided by omega as the Fourier transform. So what is that you see? Yes, we know that. So let us assume that we know x1 of t with the Fourier transform given by 2 sine 3 omega by 2 omega. Now look at x1 of t and look at x of t. How do you get our x1 of t from x of t from x1 of t here? Yes, how do you get x1 of t from x2 of t? So I'll take from -5/2, I think. Okay. Okay, I'll take from -5/2, not 3/2, from -5/2 to +5/2. So here also what will happen? You will get 5. Okay, sorry for that. So let us consider this signal x1 of t. It's a rectangle from -5/2 to 5/2 with Fourier transform 2 sine 5 omega by 2 by omega. So how is x1 of t related to x of t? So if you are smart, you can see that you shift x1 of t to the right by half unit. Okay, so what is that signal? x1 of t minus half. So you shift our x1 of t to the right by half unit. Means what? So signal exists from where to where? Shift the signal, correct, to the right by half unit. So signal will exist from -2 to 3, correct. If you shift to the right by half unit, so this flow will go to -2, this flow will go to +3. Okay, oops, sorry. Similarly, yes, so let us take another signal which is x1 of t plus half. Okay, let us take another signal which is x1 of t plus half. So means what? You shift x1 of t to the left by half unit. So if you shift the signal x1 of t to the left by half, how does the signal look? That fellow will be from -3 to +2 with amplitude 1. Okay, now something should flash. So here amplitude is 1. Okay, so what is that? What should flash here? So definitely you can see that this signal x of t is nothing but addition of x1 of t minus half and x1 of t plus half. Okay, we see that. Okay, so what is that? We see x of t should be equal to how much? x1 of t plus half, correct, this guy, plus x1 of t minus half. So what will happen to the corresponding Fourier transform? So this implies x of j omega would be equal to, we should use two properties. What are they? Linearity and time shifting. So you will get x, we already know the answer, right? Okay, or else I'll write down x1 of j omega multiplied with e power j omega by 2 plus this fellow will have x1 of j omega multiplied with e power minus j omega by 2. But we already know what is x1 of j omega, which is equal to 2 sine 5 omega by 2 by omega, and that fellow is common for both, right? So you'll get e power j omega by 2 plus e power minus j omega by 2, which is 2 cos omega by 2. Okay, so that would be the final answer. Okay, so what we will simplify, we'll write down in a nice way. So this is equal to how much? 2 sine, or sorry, 4 sine 5 omega by 2 multiplied with cos of omega by 2 whole divided by omega. So that would be the Fourier transform of our rectangle signal. So you can, whatever we have seen before using linearity property, again you get the same answer. Okay, right. So we'll take second example. Okay, so what is that? Find the Fourier transform of this signal. Okay, this one, which is a rectangular signal from -4 to +4 with amplitude 1. Okay, we want to find the Fourier transform of this signal. You already know this. So what should be the answer? You should get to 2 sine 4 omega by omega as the answer. So let us see whether we get this by using time shifting property. So again, let us consider a new signal x1 of t, which is a rectangular function from -2 to +2 with amplitude 1. So let us consider this. Okay, I'll write down that. Consider x1 of t, which is a rectangular signal from -2 to +2 with the Fourier transform. We already know, which is x1 of j omega, which is equal to 2 sine 2 omega divided by omega. Okay, now if you look at x of t and x1 of t, how are they related here? So you can easily see that, or else I will consider this signal x1 of t minus 2. So how does that signal look? Shift the signal x1 of t to the right by how many units? 2 units. So what you will get? You will get a rectangular function from 0 to 4. Correct? You shifted x1 of t to the right by 2 units. Okay, so you will get a rectangle. Oh, I will keep this fellow in view. Okay, so x1 of t minus 2 is a rectangle from 0 to 4 with amplitude 1. Now let us consider x1 of t plus 2. Okay, means what? You have to shift x1 of t to the left by 2 units. So if you shift our x1 of t to the left by 2 units, so you will get a rectangle from -4 to 0, again with amplitude 1. So what should come to your mind? We want our x of t. So how do you get x of t from this x1 of t minus 2 and x1 of t plus 2? Just add them. If you add these two fellows, what will happen? What will happen? You will get our signal x of t. So I'll write down that we see that x of t equal to how much? Our shifted signals x1 of t plus 2 plus x1 of t minus 2. Now you again take the Fourier transform. This implies x of j omega is equal to x1 of j omega multiplied with e power j2 omega plus x1 of j omega multiplied with e power minus j2 omega. So this again would be, I'll simplify, 2 times x1 of j omega multiplied with cos 2 omega. Okay with that? Because x1 of j omega is common, e power j theta plus e power minus j theta is 2 cos theta. So let us substitute what is x1 of j omega. What is x1 of j omega? This one, 2 sine, 2 is already there. So 2 multiplied with 2 sine 2 omega divided by omega, and this fellow is again multiplied with cos 2 omega. Okay, so this should be equal to how much? Yes, how is this looking at? 2 sine A cos B, which is nothing but sine 2A. So you will get 2 times sine 4 omega divided by omega. Correct? So we got x of j omega to be 2 sine 4 omega by omega. So clearly, if you look at the answer, directly you get this, and by using time shifting operation also we got the same answer. See, 2 sine 4 omega by omega. Okay, so in that way we can use linearity and time shifting property in sync with each other. Okay, as a last example, let us take to find the Fourier transform of this signal. Okay, so we are interested in finding Fourier transform of this signal. Okay, so this is the rectangular signal from -4 to 0 with amplitude 1, and from 0 to 4, sorry, this amplitude is -1. So let us call this as x of t. So we can relate this signal to the previous signal. Why? So there we have defined x1 of t as what? Oops, sorry. Yes, so we can relate our signal x1 of t as what? It's a rectangle from -2 to +2. Okay, so you shift this to the left by 4 units, you will get this upper part, right? And then you shift to the right by 2 units and then multiply with -1. Okay, so we can write this as what? x1 of t plus 2, which is rectangle signal in the previous problem, shifted to the left by 1 unit, minus and the same rectangle signal shifted to the right by 2 units. Okay, so this implies what will happen to the Fourier transform? We get x of j omega to be equal to x1 of j omega e power j2 omega minus x1 of j omega multiplied with e power minus j2 omega. Okay, so that should be equal to 2j x1 of j omega multiplied with sine 2 omega. Okay, but we know that x1 of j omega is how much? I'll write down that 2j multiplied with this, we got to be 2 sine 2 omega divided by omega multiplied with sine 2 omega. Okay, so again this should be equal to how much? So 2j by omega, I will keep it out. So this would be what? Sine square 2 omega, which is nothing but 1 minus cos 2 sine square omega 2 omega can be written as 1 minus cos 4 omega. Okay, so this would be the Fourier transform of this signal. Okay, so this signal will have, this has the Fourier transform. So in that way we can take the help of linearity and time shifting property to find the Fourier transform of these example signals. Okay,